participants on the group. So based on their features, for at this moment, was there a question? Okay. If there are any questions, I'll answer in the last, sir. So based on their features, at this moment, let us not go too much into details, but based on their color, like gray, blue, and yellow, what we try to do is we segregated those 11 of them into 3 classes or 3 segments. It's like you have 5 here, another 5 here, another 5 here. You might say there are 11 there, and how did you come out to 15? Just for your understanding and understanding the inference out of it, just assume there were 15 of people in 3 different segments, and then you have to classify them, or you have to basically cluster them. Let me not confuse you with these 2 words, though SPSS uses classify and cluster together, but I do not want to confuse you, because classification is by itself another area of research in where you see methods like logistic regression, decision trees, random forest, support vector machines, and then of course you will at the last have XGBoost, AdaBoost, and then the neural network based models. So that's classification. We'll not talk too much about it. So clustering is about bringing out those bunches in it. So one classic example that you should see is clustering is absolutely not new. It is approximately a 95-year-old technique, in fact. So this is there since 1930s. But firstly, we will understand the definition that is laid for cluster analysis. Cluster analysis says you have to classify your cases. Remember cases here. Whereas in factor analysis, you have segmented your, or you have grouped your variables into dimensions. Here, you are classifying the cases. Cases is like, suppose you have data collected from 100 people. 100 is your total number of cases. Okay. So now you have 100 people's data collected, and preferences that you have, you have collected 100 people's data, and you have collected the preferences of theirs while watching a television. So through this, you probably assume that you are a television making company like LG, Sony, or Samsung, and now you would like to assess which particular group should we be basically targeting. So this is a classic marketing problem. So while if you want to target a specific group, I don't have to reach out to 1 lakh people who are probably in the area of Warangal. Rather, I would probably target a bunch of people whom I think I can sell LG TV or Sony TV or whoever company I'm working for. So this is the beauty of cluster analysis. So what it does is it actually groups similar cases, like out of the example that I said, to minimize the number, out of 100, if I'll have to minimize them into 3 groups or classify or segment them into 3 groups, I can actually segment them like say 40 in one, another 20 in one, another 40 in one. So it could be groups of cases. So classifying cases into groups that are relatively homogeneous. Now you have to understand this. Homogeneous is which is very similar, relatively very similar or very close. So that is like, for example, in group 1, if I have categorized or put 2 customers, their preferences are approximately same. They might probably want LCD TV display or 4K display, and they might probably want higher sound systems, and they might probably want a home theater kind of setup. So assume these are the 3 preferences that they have. So if you are bringing those 2 people's tastes or similarities together, it is something called as homogeneous. Okay. Now you are bringing similar people together into a group. That is the first part of it. Now, how do you actually divide into groups? The groups have to be as heterogeneous as possible. Now that's the second part of it. Heterogeneous is as dissimilar as possible. So in a group 1, if you are probably giving high priority to people who might probably have interest towards display, in group 2, there should definitely be people who might probably have interest towards sound or something like that. So what I'm trying to say is each group will have similar people, and if you probably compare groups, then 2 different groups will have dissimilarities. That is heterogeneous. So homogeneity between the people in the group, heterogeneity across the groups. You have to remember like that. So this is what the definition of cluster analysis is. These groups that are classified in terms of cases are nothing but clusters. So this is what clustering is. Clustering is not new, but for the research of psychology, it is new. That is what I would like to predominantly mention. Cluster analysis came out in anthropology in 1932. But you know, first time it was used in understanding personality behaviors in psychology. That was in 1938 and 1939. There came out research articles where clustering was used. But some of the examples that I would like to give out on clustering will go very quick. If you have any question, you please stop me. So very quickly, some of the questions or some of the advantages that we have while we use clustering, I want to talk about. So there are, the first example that I would like to take is, you all use Google, right? Well, you probably go to Google and you probably type a word called clustering, for instance. While you type a word called clustering, you have a group of what you say, keywords, I mean, group of websites that come out, or a bunch of websites that come out on the Google. Immediately, once you type clustering, you will get a group of messages or group of websites. So how do you think that typically happens? So there also it is all pattern recognition, and clustering can actually be applied there. So when you look for something which is relevant to clustering, clustering word is typed. So anything that is pertaining to this group or related to this group called clustering, we can bring them and show it there. So that is a first classic example, and that's why clustering is called a pattern recognition algorithm, and clustering is also called an unsupervised algorithm. It is called unsupervised algorithm because yesterday, if you remember, I said you basically have regression, and regression is nothing but a dependent variable equals to the functions of the independent variables. In simple language, we said y is equals to ax plus b. So when it is ax plus b, uh, you have something called as this dependent variable, which you want to predict, and you have an independent variable, which is a predictor, which is helping you predict. So through this, what you can understand is, whenever you have a target variable or a dependent variable, and you have a prediction to make based on the dependent variable, they are called supervised algorithms. Whereas clustering doesn't really require something called as Y. It doesn't know how many groups the data has to fall into. It doesn't really have any information within the data set. It is the research person who can actually decide on the number of clusters that he wants from the data. So that is why it is called unsupervised. Supervised is like you have a supervisor to basically run it. So in the case of regression, it was that Y which is supervised, whereas in unsupervised, you don't really have anybody to supervise you or any data to supervise you. It falls into the distances, or it falls into the groups based on its own methodologies. What are those methodologies? We'll talk in some time. Now, the second example that I just mentioned is market segmentation. Market segmentation, how do you do using clustering is, like I said, if you probably want to buy a television, or if you want to sell a television or any of the products, typically, in terms of marketing, they follow 3 steps, or any product. And these 3 steps in short are called STP. So the first thing that you do is to identify your segment market. So in terms of marketing, you might probably say it is demographic or geographic or stuff like that. But if you have right amount of data with which you can actually segment people, and you can actually do that using clustering algorithm. So clustering is a methodology. Under clustering, you have several other methods as well. We'll talk about it. So the next is, if you want to identify new product opportunities, like new product opportunities, it is like what preferences is somebody giving for a particular product. If you want to understand, you use clustering. So I mean, you don't see clustering too much in the textbooks of statistics, or in fact, if you probably look into discovering statistics with SPSS or anything, you don't see clustering too much, because the application of clustering is too much considered into data mining and pattern recognition. So it was not predominantly used in management, but like I said, in psychology, specifically to the behavior of the people, it could probably be the human behavior in HR, or it could probably be the consumer behavior in marketing. As you want to differentiate, clustering has been predominantly used. So I think the applications that you can probably correlate to would be highly relevant. Even if you think I'm a finance guy, how can this be useful? Yes, when you are selling, you also sell products. You probably sell credit cards, you sell any of the credit investments, you probably give away loans. So you can segment your customers there as well. So I believe the applications across industry, clustering is a very important tool. If you want to further read, there are references. This content is anyway shared to you. So let us directly get into understanding. Okay, this is one thing that I want to tell you. Even very recently also, there are papers on clustering. So this paper is identifying or grouping fake news articles. So how is it doing? It is doing based on the tensor decomposition method of clustering. So clustering, like I said, clustering methods are many. In fact, there are many evolutionary methods of clustering as well. But today, in the interest of time and to understand the basics of clustering, we will stick on to some of the popularly used routine clustering methods, because these are some of the methods that predominantly are used in research. So what are those? So in terms of division, clustering types are of 2 types. Okay, the first type is called an hierarchical procedure, and the second type is called a non-hierarchical procedure. So under hierarchical procedure, what typically happens is you don't define the number of clusters. You don't know, you have 100 data points and you really are not sure how many data points how many groups should this data points be divided into. You really don't know. So when you really don't know, the best method that can be used for clustering is called hierarchical clustering. And under hierarchical clustering, you have two methods. One is called agglomerative and the next is called divisive. So in SPSS, predominantly agglomerative clustering method is used, which says, like, what does agglomerative does is it considers the all 100 cases as one group and then slowly divides itself into 99, 98, and it comes to 1. The opposite of agglomerative is divisive. That means it considers first point as an individual cluster, and from there it comes to group all those 100 variables. So 100 cases. So here the concept is simple, guys. What you'll have to understand with both these concepts is you really don't know how many clusters it should form into. So what typically happens is from point 1 to point 100, all of them are grouped. Now it is for the researcher to decide if he has to follow or group them into 2 clusters, 3 clusters, or even 10 clusters as per the research problem that he has designed. So this is typically when you really don't know how many groups your data has to fall into. The next method is non-hierarchical procedures. In non-hierarchical procedures, the method that is predominantly used is called k-means clustering. Here, like I said, in hierarchical, it says it gives you a hierarchy of 1 to 100 or 100 to 1. You really don't know the number of clusters that it has to fall into. But in non-hierarchical clustering or in k-means clustering, the user, the researcher can define the clusters. For example, I knew that my data of 100 points can actually grouped into 3 groups. So 3 groups are, I really want 3 groups. This is my business understanding. So when I'm so particular that my data has to fall into 3, I can define my K is equals to 3 and my groups or my data would actually be divided into 3 groups. So the beauty about k-means clustering is when the researcher knows into how many groups or segments the data has to fall, he can follow k-means clustering. But if he is not sure about how many groups or how many segments the data has to be basically done into, then he has to follow hierarchical methods. So this is what clustering is in short. Now, I don't want to directly get onto the SPSS. Typically, people leave it here and go into SPSS, but I want to give you the concept on how clustering works. And from that, you can actually understand the concept better. So let us take the concept of how a clustering algorithm works. Okay, so suppose you have 100 data cases, like I said, or let's take an example. Suppose these are 5 data cases that you had. Okay, D1, D2, D3, D4, D5 represent customers. Just assume 5 customers, and you had 2 variables of data. So typically what happens in clustering is, clustering works on, see, just imagine how clustering has to work. If you probably see, there are all these points, if you probably plot on a scatter plot, considering X and Y axes, you will definitely get 5 data points on the scatter plot. So now if you understand very closely as not a mathematician, but simply if you understand, how do you group them? So you group them based on the closeness of each point. So in a simple language, if I'll have to say, out of those 5 points, if 2 points are falling very close and another 3 points are falling very close, you can probably draw a circle across those 3 points and draw another circle across these 2 points to mention that this is group 1 and this is group 2. That's how it can be, right? So how you are grouping here is you are grouping based on the similarity or the closeness of the data. So how do you actually evaluate the closeness? In reality, what will happen is you don't have 5 data points like this. You will have hundreds of data points and they don't really show a segregation so easily. In real-time data, the segregation or division is not so easily visible on a scatter plot. So how do you do this is, the best way of doing this is following distance-based calculations. We all read this formula in our schools, probably in 8th or 9th class, to calculate the distance between 2 points. The best method that was suggested to us was Euclidean distance method. If you all remember, the formula is simple: x2 minus x1 whole square plus y2 minus y1 whole square under root. If you all remember, this was the Euclidean distance method formula. So based on this formula, hierarchical clustering works. So it's like this: Euclidean distance formula runs on the 100 data points. And what it does is, say suppose D1 and D2, D1 and D3, D1 and D4, D1 and D5. The calculations are made, and whichever point D2 or D3 or D4 or D5, whichever point has the minimum distance between D1 to D2 or D1 to D3 or D1 to D4 or D5, whichever points have minimum distance, those two group into one class. Now this repeats in the next case. D2 calculates its distance from D1, D3, D4, D5, and then based on the minimum distance that it has, that is grouped into the next cluster. So like this, the groups are actually made, and finally what will happen is all that you will see in a hierarchical clustering is finally you would get to all the 100 cases. That's how it happens. But that's how it works actually. So what typically happens is, but how do you actually group things? I talked about minimizing the distance, but how do you group things? To group things or to divide them into clusters, that is where you have certain linkage methods in hierarchical clustering. Such linkage methods, there are 5 or 6. I have taken 3 here. The first method is called single linkage distance. The single linkage distance is nothing but just imagine cluster 1 and cluster 2. How do you imagine cluster 1 and cluster 2? So in the first case, whatever is the division done, one is cluster 1 and cluster 2. Here you will have just 2 clusters only. So based on those 2 clusters, what you do is you find the minimum distance between the closest points. So in cluster 1, there will be 1 point which is closer to cluster 2, and in cluster 2, there will be 1 point which is closer to cluster 1. You calculate the minimum distance again, and that will probably be the single linkage method. So this helps in separating 2 groups while we go across. Whereas complete linkages, it looks at the maximum distance in cluster 1 and the maximum distance in cluster 2. So this is what complete linkage is. The average linkage is, it basically calculates the average of the group data in cluster 1 and also average of the group data in cluster 2. In the same way, there are advanced methods like Watt's method, and there is also a method called centroid method. So there are several methods which are typically called as linkage methods. This you will understand when we are running a simple SPSS file. So this is how agglomerative works. Now, having said all this, now I'll make it very simple. Let us try to understand how a k-means algorithm works. We spoke about hierarchical right now, right? Now let us talk about how a k-means algorithm works. K-means algorithm also works in the same way. It also calculates distance, but the method here is slightly different. What it typically happens is the user is defining its k, right? The user is saying k can be, suppose k can be 3. If k is defined, what it initially happens is all those 100 points, randomly you pick 3 points. Okay, the first step in k-means clustering is you have 100 cases. Okay, the case is simple. You have 100 cases and you are asked to probably calculate a k-means cluster with your k value given as 3. Okay, so the first step in this is you have initiated k is equals to 3. So what I'll do is I'll randomly pick 3 points, any 3 points out of those 100 cases. Okay, so from point 1, I will calculate the distance of those 99 points. Okay, from point 1, I pick 3 points, right? So from point 1, I'll calculate the distance of those 99 cases. So whichever distances are closer by, I will actually bring them together under point 1. In the same way, I have picked point 2 as well. Now point 2, what I will do is again, I will calculate the distance of all the variables. Whichever variables or whichever cases have the minimum distance will come into point 2. And in the same way with point 3 as well. Now what you have to do is, in point 1, you might probably get 20 cases. Just imagine that you get 20 cases. Calculate the centroid of those 20 cases. Calculate the centroid of those 20 cases, and based on that centroid, here earlier the linkage was made using these methods. Here you see the linkage is made automatically based on the centroid. So based on the centroid, now what you'll have to do is, you have a new point formed. In 3 cases, you will have 3 centroids which are new points. From this centroid value that you have as a new point, again calculate distance for all the data points. So the first step that I have said is 1 iteration, and these iterations will go on to a level where the groups can further not be condensed. That means if case 1 is falling into group 1, it will be in group 1 only. It can't again grow into group 2. So many iterations are run so that now going forward, the clusters are all set. That means the groups are all formed. Those steps I have clearly given in just 6 steps. Like I said, the number k of cluster is fixed. That means you give k is equals to 3. Initial time, you have to give those as seeds. Seeds, I said points. So the first k elements are those 3 points. Based on those 3 points, you have to calculate the closest cluster seeds. And now based on the centroid formula, you calculate the new seeds and then repeat the same process. I'll repeat it again for you guys. First thing is, you have, suppose you assume that k is equals to 2. That means you want your entire 100 points to fall into 2 groups. If that is the case, what I will do is, I will just randomly pick 2 points on those 100 data points. In the first case, what I will do is, using that point as x1, y1, sorry, x1, x2, sorry, let's take x1, y1, and then we will pick another point, like there are 99 cases, right? x2, y2. So calculate y2 minus y1, x2 minus x1, the equidistance formula using a square root, and get a value. Like this, you do it for 99 times. Whichever values are very close to group 1, you probably take them into group 1. How you will take? Only after calculating the second cluster as well. Now, whichever values are close to second cluster, they will fall into group 2. Whichever are closer to group 1, they will fall into group 1. Assume that 40 have fallen into group 1. They are closer to this particular point that we picked. Now calculate the centroid point. So centroid is like the total values. By 40, the entire things you take, it will give you centroid point. Now that gives you a new x1, y1. Now again, using that x1, y1, calculate the distance between all the points, and this is called one iteration, and this iteration keeps continuing until the groups are all condensed and will never again fall into different classes or different clusters. So this is how clustering works. So clustering, in short, if you have to take away key things, it is a distance-based method. In short, if you'll have to remember, it calculates the nearer, closer neighbors, and it brings all of them together. And how does it do this? This is done using equidistance method or squared distance method, or there are several other distance methods, but the predominant usage is Euclidean or square Euclidean methods. So using
Excuse me,
this,
sir. Excuse me,
yes,
sir. Sir, out
yes,
of
please.
100 cases, suppose we are to divide those all into 4 parts, means 4 clusters. So
Yes,
it is up to us now, that in which means how many clusters we are to divide the whole sample.
yes, ma'am. So,
Huh?
ma'am,
That is why it is k is equal to 2. Means you have assumed that into two
exactly,
clusters you want. Huh? And
exactly.
earlier you were talking about that k, assume that k is equal to 3. Then,
Yes.
huh?
Correct, ma'am. I'll probably take 1 minute to clarify your point. Then, if
Fine.
I probably have not missed anything, you add. So, what we are trying to say
Okay.
is,
Thank
assume that
you.
you have 100 data points and you want to probably segregate them into 4 clusters. Your research problem tells you that you need 4 clusters by any chance. So, if you are very clear that you need them to be 4 clusters, you have to define your k is 4. Like how I define k is equals to 2 or 3. So when you are very sure about how many clusters that your data has to fall into, you can define your K as you want. When you are not sure about how many data points your cluster typically falls into, the method that you will have to use is hierarchical clustering. Madam, please unmute and now add up or follow up what you wanted.
Sir, hierarchical clustering means if we are not like assume that
Yes.
into how many parts we are to divide that.
Exactly. So see, madam, sometimes the research problems are something like you really don't know, or you want to see how your
Yes.
data is actually segmenting it. You are not sure about how many segments it has to fall. So in such
Yes.
cases, you have to use hierarchical clustering. When you are pretty sure that your data should actually fall, sometimes the business problem is, see, I'll tell, like, I'm a television company.
Yes.
I ask my researcher, I just want 3 groups of data. That's it. I don't want, say, 5 or 6 clusters. I want 3 sets of groups in probably Warangal. I want to target these 3 groups separately. You bring me 3 groups based on their preferences. If I tell, as a researcher, now I am very clear that the K has to be defined as 3. So I have to follow K-means clustering.
Okay.
Okay,
Thank you.
makes sense, ma'am. Okay, ma'am. Since I saw you yesterday, I think you told about the scale thing, right? The scale. I don't remember if it was you.
No, I didn't tell. Somebody else.
Yeah, the scale is right, madam. It has to not be nominal. It has to be scale only. SPSS. So sorry, I forgot the name.
Okay, sir.
Yeah. So you all get it right. This is the concept of what clustering is. In short, if I'm not asking you all to solve a problem, but what you can do after this class is, I have given just 5 data points. Just try equilibrium distance based on this. If we had 1.5 hours, I would have asked you guys to do this. But now we just have 1.5 hours to finish 2 things. So you can try after this class following this procedure. Okay. Now let's try to get into SPSS and try to see how much hour we can make our hands dirty. So in SPSS, there are three methods of clustering. One is k-means, two is hierarchical, and three is two-step. So let's go back. You all have this data file, which is called cluster.sav. Can I request you guys to please open this file? And when you open this file, this is, okay, I have run this already. Okay, so what typically you will have is, you will have ID. ID is definitely the serial number. And then you will have not data points, 4 variables, which typically explains the quality of a flower. So this data was created by Fisher very, very long ago, and this is ideally used for clustering methods as an example, and this is a very, very popular method for clustering. If you probably type iris dataset, you will get lots of examples with which clustering can be done. And sometimes this can also be used to solve classification problems. So this is a classic dataset. So what Fisher did is, he went on to look at 3 species of flowers. One is called setosa, the next is called versicolor, and the third is called virginica. So he looked at 3 species of flowers, and what he has created is how you basically identify a flower. He said the flower identification can be made on these 4 characteristics. One is called sepal length, sepal width. So length of the sepal and sepal's width. Petal is the leaf, the petal's length and the leaf's width. If you can, based on these factors, what he says is you can actually categorize your flower into these 3 classes or 3 groups. That is what Fisher meant by creating 150 data points. And in this, it is so organized that 50 are setosa, 50 are virginica, and 50 are versicolor. So he made 150 data points with 2 equal segments, and this data is thus created. This is the description of the data. Can you all please confirm if you have not still opened the data file and you have some difficulties? Okay, I think there are no difficulties. Done, open. Thanks, sir. So, okay, so this is how the data file looks. Okay, for a moment, I know, I mean, again, the same scale issue is here. You can probably change them out because they are points, so you can convert them into scale. Doesn't matter, you know, clustering even runs with ordinal scale, doesn't matter. So I've changed them. So what I'll do is, you just forget this is the output. You just forget these 2 points which I have highlighted in blue. Just I'll take these 4 points, and based on these 4 features of a flower, I want to segment them and see how it works. So the first point is, let me assume that I don't know that this entire data is divided into 3 groups or 3 flower species. Let me assume that I don't know. Assume that I have not been given variable 007. So what is given to me is only these 4 data points, and at this moment, what clustering method should I be using? This is a question. Yes. What method?
Hierarchical.
Yes, ma'am. Yes, madam. I'm sure it was you only, right? Yesterday you reminded me about the scales. This time also.
Yes, Sushma. Yes,
Yeah,
sir.
yeah. Thanks, ma'am. This time I didn't go wrong. So now, like ma'am said, since I really don't know into how many clusters I want to categorize this data, the best way of working on such kind of data is first run hierarchical clustering and then run k-means clustering. Why I'm asking you to run k-means clustering, I'll tell you in a while. But first, let us run hierarchical clustering. Okay? Go to analyze, and then you have something called as classify. Anytime if I'm going little fast, please do stop me. I'm trying to go fast to make sure that I'm doing what I'm asked to be doing. That's it. So under classify, you have 2-step cluster, k-means cluster, and hierarchical cluster. And also there is a method called as cluster silo it is. So, but our focus will be too much on hierarchical and k-means. And if I'll give some brief on what two-step cluster is all about. So give a click on hierarchical clustering. All of us with me till here? Anyone want me to hold on? Okay, I hope you are all with me.
Yes, sir.
So when you open, I just ran this to make sure it doesn't happen like regression yesterday. So what you'll have to do is take the sepal width, sepal length, petal width, because based on these 4 features, I want to segregate my flowers. You select them and then push them into this class of variables. Push them into variables. Did you all do this?
Yes, sir.
Okay. Now you have 4 options here. Let's see what are these options. Let's see.
Excuse me, sir. Your data has changed into ordinal, no, sorry, nominal, and R is means mine is in scale.
It has to be in scale only, ma'am.
No,
My
your one is being shown in ordinal.
it is
That is
showing
nominal.
in nominal. See,
Yes.
I tried to change them. See, if you see on this, it is changed,
Yes.
but I
That is
don't
why.
know. It has to be
Yes. Yes.
scale only because
Okay.
the data points are 1 to 10 or 1 to 20. It is like
Okay.
the length and width of the flower, so it has to be
Okay.
correct. Your scales are right.
Okay. Thank you,
So
sir.
yeah, so for a moment, you all have fixed them, right? 1, 2, 3, 4. All of them have been pushed here, and anyways, we want the display of plots and statistics, and we want the cluster by cases. It is like by the number of groups, I mean number of people or number of flowers here. So now the first step that I'll be doing is statistics. I'm giving a click on statistics. When I give a click on statistics, you all just saw what is agglomerative. Agglomerative is it starts from n and it finally goes till 1. So that is the method that it has to run. Proximity matrix. The proximity matrix just gives me the distance values. If you want the distance values, give a click on it. Okay. Cluster membership. I really don't know what are the clusters. So I don't want to touch base this and give a click on continue. If I again repeat, if you don't want, you can give a click on it. If you want this, you can, these are all just the statistics that you want to see on the output results. Okay. Statistics clear, right? Moving on to plots. When you give a click on plots, the most important thing on how you can actually classify or group things on clustering is it's like this. It looks like a tree. If you all remember how from a branch how another 2 branches evolve, that's how dendrogram is. A dendrogram is a pictorial representation of how your clusters are segmenting or segregating into. So that is dendrogram. So I would recommend whenever you are doing hierarchical clustering, you give a click on dendrogram. What is it? Please do hold on for 5 more minutes, you will know. And the next thing is, I don't have any specified range of clusters for the ICICL. So what I'm trying to do is, I leave it as for all the clusters at this moment. And orientation is how you want to see it. Then the next most important aspect of clustering is to give a click on method. In method, we spoke about some of these methods. If you all remember, I spoke about uh, between groups, within groups, linkage. And then I spoke about nearest neighbor, yes, and the farthest neighbor. These are like simple linkage and then the average linkage that we spoke about. Centroid clustering is like it is grouping based on the centroid formula. And the Watts method is one of the predominantly chosen method these days. With this, what it typically happens is it calculates the average squared values in a cluster. Earlier case it was centroid, but here it calculates the average squared values of a cluster. So in short, if you guys are very much not specific about what to choose, the recommendation made is you can either choose between groups or within groups or a Watts method. So I am clicking on Watts method, and the distance calculation is made on Euclidean distance method. I said predominantly if you don't click on anything, SPSS gives you an option of clicking squared Euclidean distance method. So you can use Chebyshev or you can use Pearson or you can use cosine or any of these methods that are there. So let's continue with the squared Euclidean distance method only. Okay. So this is all that clustering in hierarchical clustering is all about. What I'm trying to say is, as a user or as a researcher, you have choice of picking the method with which you have to group things and how you want to calculate your distance. So that is what you can do using clustering analysis. So give a click on it. So save, again, I'm not using anything here. So this is all that I have done. I hope you all have also done something, I mean, not stuck anywhere until here.
Done, sir.
Yeah. Okay. So now give a click on OK. So you should now be led to your output file. So this is how your output should come. In case I gave a click on proximity matrix, so proximity matrix has also come. If you have not given a click, it will not come. You all know the simple points on how you basically look at the SPSS chart, right? You get all the headings here, so I'm not talking too much about it. Let's directly get into the interpretation, which is the most important point. So case processing summary is giving you the summary of your data. You have 150 data points and all 150 are clear. There is no missing data. If there was any missing data, it will show what the missing data is. And how do you want to do the linkage? That means how do you want to segregate your clusters? That is the method that I have given click is the word linkage method. Okay. Using the word linkage method, like I said, every case gets connected to the other case. So it's like 150 times you will have these values. 150 times each case to case, the distances are calculated, and the distances using the equilibrium distance method, these are the values that you get. So that is what proximity matrix is. You don't have any interpretations to make out of it, but this typically gives you what are the distances between each point. The most important point is this agglomeration schedule. This is the most important point that we will be using for identifying our clusters. Like I said, always in agglomerative or in decisive, each stage your clusters will be into 2 only. So if just assume there are 100 data points, what will typically happen is you will calculate that one data point to 99 data points. That means whichever is closer out of those 99 data points to this one, that will come into the second group. That means clustering is always done as cluster 1 and cluster 2 only. You will have 2 clusters with which you can actually segregate things. That's why you see in each stage, how many times the stages have probably occurred to, they will occur approximately to 149 times. And in each stage, if you see, cluster 1 and cluster 2 are there, and its coefficient values are there. Our significance is about this coefficient values. These coefficient values are something that we are going to use for our analysis. These coefficient values, so how we'll do is, we'll come from the bottom, guys. Very, very careful. Please listen. So from bottom, we will come. We will see the coefficient values. The 149th value that I see is approximately 680. If you guys have also used word method, you should get 680. And then the 148th value is 155. You see, there is lots of difference, close to 530 data points of 530 coefficient value difference. And then you see the next value, 155 to 79, which is approximately a difference of 70 again, 75 in fact. Then go to the next point. You see the difference, 79 minus 58 is only not even 21. So it's like 21. Then go from 58 to 47. You see the distance is only 11. So what I'm trying to tell you is, just calculate the difference between the last point and the last but one and to the last 147th point. You keep calculating the distance, and wherever you see the distance is minimal, stop there. So in this case, what I'll do is 680 to 155, the distance is maximum. So I'll go to the next step. 155 to 79, the distance is maximum 75 points. I'll go to the next step. 79 to 58, the distance is close to 21. The next step, if I go, the distance is 11, and the next step, it is again 11. So here I see that it is becoming close. The distance is coming closer to those values. So to me, if I'll have to make a decision on this agglomerative schedule, I will say the cluster can fall into 3 cases or 2 cases. How? So if you see 680 to 155 or 79, these 3 points, I see there is a large distance. So what I will have to do is, these last 3 points, I have to count 1, 2, 3. So I can say as a researcher, this particular group or this particular data can fall into 3 clusters. Again, there is no hard and fast rule. Everybody should say 3 only. If somebody feels 75 to 155 also, if you see there is only 75 data points of difference, rather I will only go with 2 clusters, because it depends on the data problem that you want to solve. If you want more data clusters or more groups to form, you can even take the 146th data point and say, I want to divide them into 4 clusters. But if you want to divide them into minimum groups, you can also divide them into 2. So the simplest way of remembering the formula to do this is, you have 149, and suppose if I'm taking the value still 79, I'm taking them into 3. So the way of identifying your clusters is number of cases, that is 150 minus 147. So 150 minus 147 is 3. So from this hierarchical clustering or the agglomerative scheduler, I am trying to say this data falls into 3 clusters. I am not saying this is a hard and fast rule, but the rule of thumb is, please do calculate the difference of the coefficient distance. And wherever you see the difference is very high, please go to the next level. And whenever you see the distance is minimized, please do stop there and calculate the clusters. This is a rule of thumb of how you identify the clusters. Any questions here? Yes.
Excuse me, sir. Can you please repeat it, sir? Coefficients, how we have to subtract, sir?
Yes, ma'am,
So
I'll do that.
here we have 3 clusters, right?
Yes, sir. Okay, any other questions except Jyoti ma'am's? Okay, so I'll repeat it for you. Madam, carefully, all of you, please do open your agglomerative and come to the 149th case. Okay, so when you have come to the 149th case, you will see the coefficient value is 680. And the 148th case, the coefficient value is 155. The simple thing that you'll have to do is you will have to bring in the difference between 680 to 155. That is 680 minus 155. That is approximately close to 525. All of you clear? 425, sorry. All of you are clear on this point? Madam Jyoti madam, is it making sense?
Yes, sir. Yes, sir.
Okay. So that's how you have calculated the difference between 149 to 148. Okay. In the same way, now calculate the difference between 148 to 147, which is 155 minus 79. And you get a value approximately close to 75. Okay. Now go forward and calculate 79 minus 58. And keep doing it. 58 minus 47. So you see, while you go up, you'll always see that the distance or the difference between your coefficient values is actually reducing. This is definitely there. So wherever you see the distance or the difference is actually reducing, stop there. I'm not saying hard and fast you should stop at 79 only. If your problem or if your research problem says I want more clusters, go till 58 also. But here I am actually stopping at this particular point called 147. And I'm counting how many are there from 147. So 147, 148, 149, 3 are there. So I'm saying I am actually dividing this entire set of 150 classes into 3 groups. Does this make any sense now, ma'am, or should I repeat? I can repeat 3 more times if you want, because we are dividing the cluster into 3 groups.
Yes, sir. I understood, sir.
Thanks, ma'am.
Thank you,
So
sir.
now you have 3 groups. This is the methodology of how you run hierarchical clustering, and you get to understand how your clusters have to fall. If you all remember, we said we are following agglomerative clustering, and that is a classic example of this dendrogram. If you see, all the points n sample or 150 samples are together, and finally what will happen? They will all fall into one cluster, and that is what this dendrogram is representing or pictorially showing you. So it's like 100 becoming 99, 99 becoming 98, and finally they fall into one group. So that's what agglomerative is. If you want decisive, you have to just see from one cluster to the 150, right? That means you see from left to right. Am I making sense? Sorry, you have to see from right to left. If you are right now, you are seeing from left to right. That is agglomerative. If you want to understand divisive, just see from right to left, this side, and you will understand what is divisive. So this is hierarchical clustering in short. Now, the mathematical methodology of clustering here, I mean, you have run this, everything is fine. But the user or the researcher wants to know, okay, I got 3 clusters. Now what, how do I know which cluster value or which case is falling into which cluster? This is most important. For me, to solve the problem, I want to know, like, case number 10, it fell into which cluster? Out of those 3 groups, it fell into which cluster? I don't know. So for that, I would recommend, or in fact SPSS recommends, you use k-means clustering after hierarchical clustering. If you knew directly what is your k, directly use k. If you don't know what is your k, you are requested to first use hierarchical and then use what is k-means clustering. Okay, k-means clustering, give a click on k-means clustering, all of you. Now, the only thing that you'll have to do is, you know the number of clusters here, and we have decided it to be 3. Okay, all of you with me? So, and then same way, put those 4 variables there. Okay, and here is this iteration thing. I told you guys, right? The first time the centroid is calculated and distance are calculated. Then again centroid is calculated. This is considered to be 1 iteration, I said. In that way, how many iterations you want, you keep. But the clustering will converge at a point and it will tell you how many it is. I'm putting 20 at this moment, and you will know about it more in a minute. Save. This is very important. Give a click on cluster membership for sure. So when you give a click on cluster membership, the cluster membership will be saved in your input file. So give a click on this cluster membership. This is what is going to tell you into which cluster did your each case fall into. So give a click on cluster membership and give a click on continue. Okay. And then give a click on OK. All of you, me or anyone stuck anywhere? I mean, so sorry, you are all doing with me, right? Or
Yes,
I'm
sir. Yes, sir. I got it.
Sir,
Yes,
can you
so
please
sorry.
repeat once again, sir?
Yeah, thanks. Which one should I repeat, ma'am? K-means or hierarchical?
Hierarchical, sir.
Hierarchical clustering.
Yes, sir.
And what specifically should I be repeating, if I can ask?
K-means
From the
K-mean, I'll repeat, sir. So what should I be repeating, ma'am? Should I be repeating how your clusters are formed,
yes,
or
sir.
from the
Yes, sir.
start? Okay. For people who have understood, please do bear with me. I know I still have only 25 or 30 minutes. Madam, you have to probably get to this table called agglomerative scheduling, right? So you have
Yes, sir.
149 data points on this, okay? And the third variable or the third column has the coefficient values. So you might be seeing, you might have had 680, 155, 79, like how I have also, right?
Right, sir.
So first thing that I'm trying to do is just take 680, ma'am. 680 minus 155, if you do, you are trying to understand the difference between 149th point and 148th point. So you'll approximately get a value, ma'am. You'll get approximately a 425 or 430 value, right?
Yes, sir.
Same way for 148 to 147 also find the difference. You'll get a value close to 75 or so. Make sense, ma'am?
Yes, sir. Yes. Understood,
Okay.
sir.
Yes, and the same, this repeats to 147 to 146, 146 to 145. You can go as much as you want based on the research problem that you are solving. So now, if you observe in our case, from 146th point to 145th point, if I'm calculating the difference, it is just coming out to be 11, madam. And in the case of 145 to 144 also, it is just coming out to be 12 or 11. So I see the distance are coming closer by and are similar. So I would stop at the 76 or 79 only and decide that my cluster would, ideally be this last 3 points. How? So since I stopped on 79, I didn't go forward to the 58, 47. I am counting whatever is left over remaining from 147 to the bottom. So 147 is 1, 148 is 2, 149 is 3. In a simple language, if I'll have to say, your total number of cases minus 147 is what you should do. That is the mathematical notation. But for you to remember, just count them as onto the bottom and see how many are there. So you have 1, 2, 3. So based on this, I am saying my clusters will be divided into 3. Now, does it make sense, ma'am? If you really didn't follow, you say I didn't. I'll try again, ma'am. Not a problem. Does it make sense to you now?
Yes, sir. Got it, sir.
Thank you. So now another sir asked, how did you, probably if you have 1 minute, you want me to take me to analyze and k-means, right? So go to classify, click on k-means. Now I know that I have divided based on my hierarchical into 3 clusters. So I give 3 here. And I would actually get my sepal width, sepal length, petal width into the variable case. And iterations, I said, if you all remember, when we do k-means, I said, first time k is given as 3, so it randomly picks 3 values and it calculates equidistance and then calculates the centroid. This is all called as one observation or one iteration, I said. Like this, several iterations do take place until your values are confined into a group. This is what I told. And that is what this iterations is. At this moment, I gave it as 20. Okay. The next important thing that you should remember is I gave a click on save and gave a click on cluster membership. This is very, very important for us because this cluster membership saves in our input file the cluster into which our case is falling into. You will see in a minute. So give a click on this and then go to continue and then give a click on OK. So now this is what it happens to be. So this is the result that you get. The initial clusters are, see, sepal length in cluster 1, the average, suppose 20 points fell into cluster 1, the average values of it is 8. You don't say like you have 8, 4, 7, 12, which is only approximately 16, and here you have 12, approximately only 50 points are seen here. The point here that is being explained is what is the mean value of each of the cluster in context to each of the variable. So iteration history, if you see, convergence has occurred in iteration 5 only. Though I kept 20, in 5 only it converged. It didn't further group into any of the clusters. So this is what has happened. And finally, these are the results. Number of cases in each cluster. In cluster 1, 38 data points fell. In cluster 2, 50 fell. In cluster 3, 62 fell. But if you see into reality, each of them should be 50, 50, 50. But yeah, this is an unsupervised model. It has some error. Sometimes even if you with IUC, you see a leaf and you might probably say a wrong plant name. So this is after all a machine which is running on an equidistance mode, and it will show errors. So this is 38. Cluster 1 or class 1, 38 fell, 50 fell in this, and 62 fell in this. Now go back to your input file, cluster.sav. In cluster, I ran it for 3 times, so I have this QCL 3 times. But if you see, all the points will be same. So this is what I'm talking about. You will get, when you clicked on the cluster membership, you will get this blue variable or column. So what typically happens is, this tells me data point 1 or case 1 fell into class 2 or cluster 2. Whereas data point 58 fell into cluster 3. Data point 113 fell into cluster 1. Now the benefit of this is, what you can do is, you can take all these data points and summarize very nicely, saying these data points are falling into segment 1, these data points are falling into segment 2, and these data points are falling into segment 3. Now you can go back to your boss and say, sir, you asked me to divide this data into 3. I divided, and I'm also telling you which case is falling into which cluster. He'll be very happy. This is all cluster analysis is about. These are the methods that we typically use. And for your convenience, when you have large amount of data, running a hierarchical clustering and looking at agglomerative schedule is very difficult. You can't get to a clarity on it. These difference calculations, sometimes you may even get 25 clusters. So it is painful. So for that, SPSS has made your job little easy and has created something called as two-step cluster. So with this two-step cluster, what you'll have to do is pick your variables, and if they are categorical, put them in categorical. If they are continuous, put them in continuous. For us, it is continuous, so I put them in continuous only. This works on a clustering criteria which is called as BIC and AIC. About that, I gave you notes in the last slide. You can read more. And what I'm telling is, you determine the number of clusters is asking me. Maximum the number of clusters should be 10, I'm saying. Okay, I'm saying you can't have my clusters more than 10. I'm telling this to him. And here you don't have too many options to play with. Just give a click on OK. All that you will see is automatically SPSS, give a double click on this. SPSS has helped me divide this data into 2 clusters. It did divide into 3. It divided into 2. Like I said, the resource person can take a decision, and you can even convert them into 2 clusters, I said. Same way, this has clustered the data into 66.7% of the data into cluster 2 and 33.3% of data into cluster 1. So this is what two-step clustering is. This is not absolutely used anywhere else. Only in SPSS this application is there, with which you can actually flourish and do some wonderful analysis when you have data points of 1000, 1200, or say 1500 to work with. So that is why two-step clustering is created. So this is clustering in short, guys. So I think we'll take 2 minutes to take questions.
Rahul sir, can we also add demographics into it?
Yes,
Demographics
absolutely.
along with scale.
Absolutely, you can add your demographics. That is why we have categorical variables also to be considered, ordinal variables also to be considered in clustering. There is no problem in considering any values.
And then how to name a cluster then? For example, in your plants, you have given the name, then how to give the name to one cluster?
No. See,
By
point
what?
is, sir, Vinod sir, very clearly, in my example, Fisher knew what those plants are. In your example, you will not know into what segment or which category your customer would fall into.
Correct.
And that is why you are doing your analysis. And while you do your analysis, like you saw, Fisher said each of your flowers are 50, 50, 50. But if you saw in my K-means clustering, 1 second.
Yeah, it was 38, 50 and different,
Exactly. So that is how the segmentation would happen. It might not be accurate. See, by learning the fundamentals of confidence levels, we are clear that statistics also has errors. So that way your classes of customers will be segregated into.
Okay, so what I was asking is now how to name. For example, I have got three clusters. Now on what characteristics I would define this cluster 1 has this characteristics, and this is how it makes different from cluster 2.
This is where you have to bring in factor analysis. Okay. So use your factor analysis. Well, you probably look at your factor loading scores. You will know which of those dimensions are actually giving you a lot of significance. Okay. So the application is very good. Actually, after doing clustering, you can do factor analysis to tell which of those variables are giving significance. So very good question, sir. I think that's how the applicability will grow.
Okay.
So,
For example, if I'm doing a loyalty study where I want to classify customer based on various parameters, that which is a loyal one, which is not a loyal one, then how should we go about and cluster to classify? We have collected data on loyalty. We have collected data on various
sir,
independent variables.
another simple way I'll tell you, it's a crude way. What you can do is take your cluster 1. In this case, it has 38 data points, right?
Okay.
And you have suppose 4 variables here. Just calculate the average of each of these data points and you will know, like customer is highly satisfied, assume. You will probably get the average to be 4. That tells you that these people are 2 satisfied people and the rest of the groups are not so satisfied people.
Done. Thank you. Thanks a
That
lot.
is the easiest way. A crude way, I don't know if it is there in research or no, but it's evident, right? I mean, whatever we can do and it makes logical, we can.
Done, sir. Thank you. Thanks a lot.
Yeah. Nikhil Singh Charak, sir, what kind of research problems can we use cluster analysis for? Sir, I'll just give you a simple criteria. Anywhere in reality, you have, when research is being done, you know how typically people are trying to segment their customers. You can probably take credit cards or you can take any of the products that you sell. Typically, you want to understand or segment customers. So the customer segmentation is where one proper area in which management research you can use this. If you want to segment people based on behaviors, you can use that. You can also use clustering. I gave a very classic example. While you probably look for any word on Google, it also applies to be a pattern recognition method, and clustering is used in some cases. So with clustering only, that bunch of for example, you go to Google and type cluster. When you type cluster, you get this bunch of say websites, right? This is also based on clustering only. So these are some of the examples of clustering. Make sense?
So for students, I can also do clustering in terms of their behavior, right?
Yes, ma'am. Yes, yeah, it can be any physical person. You can do study based on their behaviors only. Like say, when I'm trying to segregate the segments of people to buy my television, I'm doing it based on their preferences, which is part of their behavior only.
Got it. Got it.
Yeah. Okay. So very quickly, please do excuse me, but I would now move on to regression. If you all allow me, we'll go very quickly to regression and I'll show you some interesting insights out of regression for somebody who is a newbie and for somebody who feels like this is not so. Sir, run, sir. 15 minutes, I put this, sir. So for somebody who is new and somebody who feels like you have done a very good job on regression, you might probably not like this, but it's like a refresher to you guys as well. So let's go and understand what regression is in 5 minutes. Like yesterday we spoke about regression, but just to give you the context or set the context. Like I said, so this is what a best fit line is. So this red line is best fit line and then you have data points. How does this best fit line calculate to? I said there is some amount of mathematics which we should understand. And this mathematics is generated based on any of the distance-based or optimal distance-based models. It could be an OLS or it could also be a least square method. So here, just imagine that we have used least square method with which you have plotted this red line. And the dots are the blue dots are typically the data points. And the difference or the distance from this line to the data points is considered to be error. Based on this, we said y is equals to mx plus c. So you see, I have probably plotted this red line till the y-axis. So from this y-axis point on red line till the origin, if you calculate, you get the intercept and slope. So it's like how you get your a and b coefficient values and you go ahead. But if it is a multiple linear regression, how do you do that? In the same case, have your dependent variable on y. Here, I just took one x1, but you can take x2, x3, x4, x5 as well. And you probably the graph would somewhere look like this, and you can generate this equation and get those results. So this is regression in short. So if you see in my slides, yesterday, it was a very logical question that you asked on probably explain assumptions. Explaining regression without assumptions doesn't make sense, but yes. Here, I have given 2 points, assumptions 1 and assumptions 2. I would recommend you guys to go through this. Some of the assumptions of regression are, it should pass through the multicollinearity. That means there should not be any close correlation or collinearity between your independent variables. And then it has to be linear. Yesterday, somebody asked, how do you do a linearity test? The best way of doing a linearity test is to see the dependence on the 2 variables. Like correlation also can be a very good linearity test, ma'am. So I also gave clustering notes and correlation notes. These are the notes that you can refer to, and I'm sure you'll enjoy it. So let's go back to what is regression. I shared one slide or one data file which was called datafile1.sav. So this typically is the data. Like I explained yesterday, you have injury levels of women and you have 5 data points which are quads, gluts, abdomens, arms, and grip. The description of this data is anyways there on the slides that were already distributed to you. You can kindly look into them. So now right away, without wasting any time, I hope you guys have opened the file.
Yes, sir, please.
Yes. So sorry, I'm hurrying up, but yeah. So go to regression, and in regression, like I said yesterday, there are several methods. All that we are focusing on this time is the linear regression. So see, remember, when you say simple linear regression, it is just y is equals to ax plus b. But when you say multiple linear regression, you have too many independent variables. That is y is equals to ax1 plus bx2 plus cx3 plus c. So that is multiple regression. So just remember that. So when I gave a click on linear, what I'm trying to do is I'm putting injury on dependent because that's the dependent variable, and rest of the 4 variables I'm putting on independent. Yesterday this question came. So when you say method, there are 5 methods. What should I use? Yesterday somebody asked. See, how does regression calculate? Regression class. Yes. So regression calculates based on, it is like y is equals to mx plus c. If you have 4 variables here, it has to calculate ax1 plus bx2 plus cx3 plus dx4. So I have 4 variables here. So if I just want to give a routine regression equation, I can just give a click on enter. But if I want to do this stepwise is like, first I will only take y is equals to ax1 plus c. Then I will take y is equals to ax1 plus bx2 plus c. If I want to do this and see which of these variables are in fact, you have this t-test, which I'll show you in 2 minutes, with which you can tell which of them are significant. That's stepwise typically. So if you want to go forward or backward, remove is like remove entirely everything. Forward or backward is like if you want to go ahead and probably take first variable, second variable, third variable, fourth variable, and fifth variable and run like that. That is basically backward stepwise, forward stepwise, and backward stepwise is take all those 5 variables, run regression, then run with 4, run with 3, run with 2, run with 1, and show the results. So these are different ways of running regression. The reason why this is important is in some of your examples, you might probably want to run regression and see how each of the variable is impacting, or each of the independent variable is impacting. In such cases, you can use any of these methods. If I have time, I'll show you stepwise as well. Then the next thing that we'll have to see is plots. Under plots, this is an interesting feature under regression. So you have ZPRED, ZRESID, and all this. What are those? If you want to see, I have a simple plot here. So here under PRED, what you typically have is unstandardized predictive values. Under ZPRED, what you have is standardized predictive values. So these are what the graphs are, or the plots are. Through this, what you can do is you can satisfy some of the assumptions. One assumption that regression has is your normality should exist between your residuals. So if you have to study that, what you can do is you can pick this and this into your x and y axis. Like say, pull this into, remove this off, and probably pick this into this and pick this into this. This is clearly there in the content in the last slide that I gave. Give a click on continue. Okay. Then we have save options. All this content, I have shared one more slide and that it is there. Then you have options. Here I'm trying to pull at a 95% confidence for F. So I'm leaving it like that only. And then I will give a click on OK. Okay. So my regression is run and I will go to the output file to see how the results are. So this is my model summary. It starts with this place. Okay. The model summary says, my R value is 0.426, my R square value is 0.182, and my adjusted R square value is 1.1.
Sir, excuse me, sir. Sir, please repeat it again because mine is showing regression error. How come
Regression
I have must have like
okay.
warnings? It is there warnings. So I
Okay,
must have missed some step, I guess.
Okay, go to analyze, regression, linear. Okay, and then probably pick your dependent variable into injury and put it there, and rest of the 4 you put into independent. And then I didn't click on anything else except I gave a click on one plot. I just gave a click on one plot just to make sure that you guys understand how to plot things. This is all that I did, ma'am. And after that, I have not clicked on anything because on the interest of time, I want to show the minimum things at least. So all these are same. I just gave click on OK. Now, does it work, ma'am? If not, probably I'll leave my number with you. Probably call me on my number and we will probably meet again after this class. Does it work or it is not working for everyone?
Actually, sir, dependent value is not being shown into this linear regression. That is why it is the
No,
problem.
no.
So it worked for us. Yeah.
Yeah. So, ma'am, what you'll have to do is, ma'am, you'll have to take. Okay, let me show you one more time. See, ma'am, under analyze and then go into regression, linear. See, here what you have to do is click on injury. So, for example, see, madam, ideally you'll have something else. Right? This is how it was first. So I clicked on injury and I pushed it into dependent. Rest of them, I'm clicking and pushing them into independent. That's it. Now you get. Okay? Okay. Yeah. So the model summary explains very important thing here. See, R square and adjusted R square are some of the things that you should know. Okay. So R square and adjusted R square are two important things that you should know. R square explains the variance of your data and typically would lie from 0 to 1. And if you convert it into percentage, what it tells me is from the data that you have, from the independent variables, those 5, the prediction of injury is able to be done for 18% is what my R square value is telling. So typically the challenge with R square value is when you probably bring in another variable, it will increase. If you bring in another variable, it will increase. But when you use adjusted, there is mathematics behind it. But yeah, for now, if you use adjusted R square, what will happen is adjusted R square takes the degrees of freedom into consideration and it makes sure that it doesn't get too much what you say, partialized towards a new entrant. That is why you see always your adjusted R square value will be lesser than your R square value. So the formula would be something like 1 minus the degrees of freedom to something, but let us not get into the formula. So now, why do you think ANOVA typically or the hypothesis testing happens in regression? The formula or the hypothesis tested here is your beta values or your coefficient values, beta 1 plus is equals to beta 2 is equals to all these values are not equal to 0. That is what we want to know. If any of these values are 0, it will be challenging. So what we want to try to understand is if beta 1 or beta 2 or beta 3, any of these are 0 or no. If they are 0, what would happen is your significance would be, I mean, the null hypothesis would actually be accepted, which would ideally say that one of your coefficient values is 0. Or say all your coefficient values are 0. If one of them is 0, it is fine. But if all are 0, it will show as greater than 0.005. But here it is showing as 0.002, which says the values are significant enough. That means all your coefficient values or one of your coefficient values is not 0. So the hypothesis here is coefficient is equals to 0 or coefficient is not equals to 0. Here coefficient is not equals to 0 or the alternate hypothesis is accepted. So how do you get this regression sum of squares and the degrees of freedom? Degrees of freedom is, in terms of regression, it is the number of independent variables. We have 5 variables, so 5. And 94 is you have data points of 99. Excluding this 5 independent variables, it is 94. So that's how this is calculated. And the mean square values are calculated based on the division, I guess. Now 49,000 divided by 5 should give you your mean score value, and 22 divided by 94 should give you your 2347. And then you get your F score calculated. F score is simply calculated as division of 9,811 by 2300. That's it. That's how your F scores comes in mathematics if you have to calculate. But otherwise you have to not worry too much. Now this is the most important point of regression. This is where you get your coefficient values. When you have to write your equation, you write like this: y is equals to mx. So mx is like 0.116. Always consider standardized values. Like yesterday we said, these are all crude values with which you can't make any inference. So consider the standardized values. And so how you can write is y is equals to 0.116 into x1 or quads plus minus 0.360 into gults and plus minus 0.97 into abdomens and stuff like that. So this is how you can write your regression equation. Now, the significance of the t-test is very important. Wherever you see your t-test values to be less than 0.05, that particular variable have significantly contributed to the dependent variable. Others have not contributed. So that is what you can see from here. Gluts have only contributed, but the rest of the variables have not contributed. Avoid constant, anyways, constant would contribute. But otherwise, others are all more than 0.05. They have not contributed anything to regression. So the charts would come like this, which would tell you the assumptions which we made. I saw if they are normally right or no. So this assumption passed and it is all correct. So same thing, what I'll do is, just for your information, I will probably click on stepwise and show how the results would be. When I click on stepwise, what will happen is anything which has a t-value which is significant only will be considered. You can see regression is run and see only gluts is considered, and it says I have excluded quads, abdomens, arms and grip because their t-values are greater than 0.005. This is what stepwise is, and the same applies to forward and backward as well. So my recommendation is, having understood the basics, that is R square, adjusted R square, the reason for why ANOVA is calculated and the coefficients are calculated with the t-test. This is the minimum thing that you should know about interpreting a regression thing in SPSS. Now, the second thing that you should do is, I would recommend you all run regression and then do assumptions. If assumptions are all right only, then you probably go ahead with your regression equation. And the second thing that you should remember is, if you have 50 data points, not all data points would contribute to your dependent variable. So this stepwise forward or backward are some of the great methods with which you can do lots of analysis. See, the drawback of regression in statistics is, you give anything, it will give you an output. But as a researcher, you should know if your independent variables are rightly given, check your t-values, check your f-values and make right analysis on it. Having said this, these are some of the references that I want you guys to follow. First and last are references. Analytics Vaidya is a beautiful site for machine learning or data science learning. So it has very detailed write-up. I thought this is very simple and you can understand. And this is another site with which you can actually understand how to each graph is also explained with assumptions. So you love it. Correlations, this is a paper which explains the appropriation of correlations. And this is the notes on clustering. It's like a chapter only. So you can read through this. Another recommendation that I have to make is, please do follow ibm.com/SPSS. Here you have every notes. Right now I said linear regression, right? So when I give a click on this, see, enter a procedure for variable selection in which all variables will be considered in single step. Stepwise, at each step, the independent variables not in the equation that has the smallest probability of your F are to be removed. Backward, forward, everything is very clearly given here. So I would recommend, instead of probably looking into different Google sites, this is the easiest and simplest way of learning. Everywhere you don't have more than a write-up of 4 lines. So this can be applied to just not regression, even to one-way, two-way ANOVAs and all that. So the beauty is, everything that is there in your regression, in your SPSS can be easily explained through this site. I'm sharing this slide on the Google Meet for anybody if you want to use. Having said this, I think I just have one more thing to do, which is to just say the references. So yesterday I spoke about this, but I thought I'll give you in writing so that you can basically be using this. I'm restricting to statistics. You may say, how can you bloody fellow recommend books to us without Andy Field? I have not recommended anything on SPSS. For me, first thing is to understand the concept. You can use SPSS, R, Python, Minitab, Stata, or any tools. We don't know which tools will probably dominate tomorrow, and as per the market is, we have to learn tools because we have to teach our students. So these are some of the books that I would recommend. And finally, I'm so grateful that you guys have patiently listened to me, and I'm absolutely so sorry for rushing through regression, but I really don't want you to probably get exceeded with my timelines and have an hindrance with the next session, which Professor Rajshekhar sir will be talking about. Thank you so much, everyone. If we have 5 minutes, we can probably take a QA session. Otherwise, if the organizing team feels like I'll overburden you, we can stop it off.
So your thank you slide, please. I'm just
So one last question.
Yes.
Sir, can I just ask one last question? Sir, it could be very silly, but it's a bit bothering my mind.
Madam,
Cluster analysis, like when, as a researcher, when we know that there are 3. Am I audible?
Yes, ma'am. It is actually echoing, so you can talk little slow also, no problem. Yeah, please go on.
Okay. Cluster analysis flowers into 3 different types. So I know it's only going to be in 3 types. Why would I further do on cluster analysis? Because already I know it's 3.
Yes, ma'am. You know it is 3, but you don't know into which group, which person or which case or which data point has to fall, right? Do you know that?
No. Okay.
So just to re-emphasize, ma'am, what I'm trying to say is, Sushma ma'am, this is to answer to your question. And Hepzibah ma'am, to answer to your question, very simple. If you know your k is equals to 3, all that you know is I want my entire 100 points to fall into 3. But into which segment should which point fall, you don't know. That is why you do cluster analysis. And that is what we showed here also. If you see very clearly, sorry, last 1 minute. So here if you see, madam, I hope you are following me. So if you see, when you ran cluster analysis, you got this blue column, right, which I have highlighted. You got it, ma'am?
Yes, sir.
So this point, it is now telling me, I know my k is equals to 3 here, but this tells me that my data point 3 has to fall into second segment. My data point called 20 has to fall into second segment. My data point called 57 has to fall into third segment. And my data point called 53 has to fall into first segment. Now what is happening is, if you assume you have 10 people in your class, you know these 10 people will either pass or fail. But who will pass or who will fail, how do you know? That is why we do cluster analysis. A very bad example that we have.
Thank you,
I think
sir.
that's the easiest way for you to get collected with. So that's the point, and I think I have given notes as well. I know all these workshops are to instigate a learning opportunity, and we will surely not be able to cover the entire crux of it, but I'm sure I gave you notes as well. And I always believe workshops are not the end of learning, but they are start of learning. I would recommend all of you all to please take these 3 links, just 3 links, in the evening times, whenever you are free over the weekend. Just go through them before you forget that you have come to this workshop. That is my only sincere submission to all the great teachers who have attended today. I hope I am not satisfied with the way I have done regression, but I think I have done at least 60% of justice on regression. Any further questions? I'll be happy to take. You don't have to worry about the time. And I have my, my website. Sorry, I don't have a website. My email ID here. And if in case you want to contact for any specific question on these 3 topics, any day, you don't have to hesitate. Please do write in subject that this workshop, data analysis workshop, MG University, and you'll get a reply in 24 hours. That is the promise that I can make. And in case, if you want my number, Ramesh sir has it. You can take it for any further help. On WhatsApp, I'm available. We can probably discuss quick discussions. We can do on WhatsApp as well. I'm poor at picking calls, but we can do quick discussions on WhatsApp. Attendance link, I don't have, ma'am. Sir might give you. Oh, yeah, this is there. I'm sharing. 1 second. Email ID again. Yeah, my email ID is just my name, man. This is my email ID. rahult@nitw.ac.in. Any questions? Or I didn't make any sense to ask questions? Okay. I think my second part is right.
No, sir. You're wonderful. It's so wonderful. Thank you, sir. Thank you.
Thanks, sir. Definitely, this is beginning of great learning. Yes, this should be a beginning of great learning. I have one of my colleague. His name was Krupakar. He was my junior. So he used to tell me this. I used to always tell him, learn Excel while you are in campus. After 6 years, when we met in 2016, he told me, you told me to learn Excel then, I didn't learn. And today my boss is bothering me to learn Excel. It is so guilty feeling that I get that I'm learning Excel at the age of 30. So my sincere advice is we can't run away from these things because we want our students to be in great professions and positions. And if we want them to be great, I think we'll have to teach them some great things like this. I don't say this is the only thing that can turn their lives, but whatever is the job market, we'll have to accordingly tune.
Thank you, sir.
Yes,
Renuka,
sir. Rama madam, what you said is absolutely true. Sir or madam, you said is true. It will take lots of time. It is not easy. I would recommend you to probably follow a simple statistics book and read into the details. It will take some time, but please take serious note of it. Good morning, Rashekar sir.
Good morning. Good morning. How are you?
I'm so sorry, sir. I think I'll close it off now. Good to see you, sir. You might probably not know me, but I have heard some of your sessions, and I probably look forward to listen to you in the future too.
Thank you. Thank you very much.
Statistics, I think you probably nail it better than anyone else.
Thank you. Thank you very much.
Yes, sir. Thank you, sir. So
Thank you.
With your permission, I think I will not further kill time. I might leave now.
Yeah, thank you. All the best.
Thank you so much, sir. Thank you so much. Look
Thank
forward
you.
to seeing you.
Thank you. Thank you.
Thanks, everyone.
Thank you.
I ask Renuka to propose vote of thanks.
Hello everyone, very good morning.
Renuka.
Yeah, hello everyone, very good morning. I would like to present vote of thanks to Rahul sir. The whole presentation is so wonderful and very much detail oriented. Today sir taught us about cluster analysis, its evolution, benefits and types, and also procedure as to how we do cluster the data. We have also revised regression and many more concepts as to how it does relate to cluster analysis. The whole presentation is so good and very much detail oriented. And also thank you Rahul sir for the resource links that you provided. It will help us, help us a lot. And even in a short span of time, you covered the topic in a very good manner, and we would like to thank you very much.
Thanks, ma'am.